And I'm actually graduate master in environmental science in University Malaysia Sabah. So today we will have a sharing session from Dr. Siti Rahayu. Welcome, Doctor. How are you?
Fine, thank you, Salwa.
All right. So before that, I introduce first what is your postgraduate volunteer, and I will show some slides here. Okay, you all can see my slide. Okay, so actually, YOSH is stand for Youth of Strength and Happiness, and it is a volunteerism unit empowered by NGO My Fun Action. And actually, our volunteer is all around the world. We are in Malaysia, Egypt, Indonesia, New Zealand, Japan, and also Australia. Okay, and okay, this is our YOSH postgraduate organization, and our head and advisor is Dr. Nurul, which is lecturer, and co-advisor Dr. Ustazah Atifa from UTP, and second co-advisor is Dr. Nurul Huda, also from UTP, and third co-advisor is Nor Sheila, also from UTP. And okay, this is our organization chart for YOSH postgraduate volunteer. And for your information, this is our team members. We at Perak, Selangor, Pahang, and we also have at Borneo, Egypt branch, and also Indonesia. Okay, actually what is programs under YOSH postgraduate volunteer. So this is a list of our program, which is we do sharing, academic sharing, and also we do technical workshop. We also invite international speaker in our program, and beside that we also have positive circle, which is we call it Feed the Soul session. It is for both Muslim and also non-Muslim, and we have Quran time reflection for male and female Muslim, and we also have annual event, which is we do it once in a year, national postgraduate seminar, future leader convention, and PGB gathering. Okay, next. Okay, this is our media social, so you guys can follow and like and follow us for the latest update and to be part of us. YOSH My Fun Action Facebook page, and we also have IG, Instagram, YOSH My Fun Action, and this our channel group Telegram postgraduate live channel. So you guys can join us in group, so we can discuss more further in this group. And this is one of our program last year. Also this one. Okay, so this is just a virality slot. Follow media social, yes, my connection Instagram, and maybe you after this session, after the sharing, you can share what is your feedback in your story, IG or your Facebook. Okay, that's all. Short brief about what is YOSH My Fun Action volunteer, and all right. Everyone is clear? Okay, so before that, I want to share one video. Let me share one video. Okay, clear. Yes. Okay, where's the video? Okay, this one. Okay. Okay, I will share one video so that you know what is my function. Where's the video? Something technical happened here. Okay, well, okay, everyone can see this video. No? Okay, wait. Okay, so okay, this is. Okay, so that is a short brief what is NGO My Connection. And actually, YOSH Postgraduate My Connection is a volunteer under NGO My Connection for your all information. Okay, so without further delay, we will continue our sharing session today. So the topic is quantitative analysis for postgraduate research, which is a quite interesting topic actually. And before we start, let me introduce our special invitation today. So our speaker today is Dr. Siti Rahayu Muhammad Hashim, and she's an expert in statistical process control and multivariate analysis. Besides, she is also a lecturer from Mathematics and Economic program from Faculty Science and Natural Resources, University of Malaysia Sabah. Okay, so without any delay, I would like to invite Dr. Siti Rahayu to give her talk. Okay, please, Doctor.
Okay, thank you, Salva. Okay, Assalamualaikum and very good morning to everyone. I hope you can hear me clearly. Do you?
Clear, Doctor, clear.
Okay, very clear. Now, thank you, Nur Farahin, Dilova, and Idayu. Thank you very much. Okay, right. So the topic today is on quantitative analysis, isn't it? So before that, let me share my PowerPoint presentation. So I will go briefly actually, on data analysis, quantitative analysis. And then because I guess some of you, most of you actually came from diverse background, isn't it? Yeah, some of you may be from research science background, and maybe some of you from social sciences background. So I'm not sure what kind of research you are doing right now. But I hope that I touch every important aspect in quantitative research, quantitative analysis for the postgraduate studies. Right. So let's have a look at the main topic here. When we talk about quantitative analysis, yeah, quantitative analysis versus qualitative analysis, right? So both of them are statistical analysis because we can actually adopt statistical method or statistical tests, yeah, to analyze your data. So, but you need to be clear between quantitative and qualitative. So when it comes to quantitative, the keyword is quantify. Yeah, the keyword is quantify. It means that you can measure. Yeah, you can measure in numbers. So some of the researchers call quantitative analysis as the numbers game. The numbers game means that you can measure something, you can estimate something, you can reconfirm something, right? In numbers, right? In numbers, okay? So normally you will end up interpret your data statistically. So it means that, in other words, you can, you can come up with mathematical judgment, okay, based on the data analysis, the results of your data analysis. Mostly students or the researchers need to use certain statistical package, or such as Pythons or SPSS or maybe Minitab or MATLAB or any mathematical programming, okay, or language programming, right? And then for the qualitative analysis, for qualitative analysis, normally we will interpret information in non-mathematical ways, okay? The focus of qualitative analysis is to answer the research question on how and why. So it's more on to identify, to determine, okay, the reason, yeah, the reason behind something that we are trying to study or investigate, right? So normally we don't really use any numbers, okay? Of course we can convert, yeah, we can convert the qualitative data into quantitative, but it is not necessary actually, because the qualitative analysis is more on understanding rather than try to formulate or represent the responses in mathematical modeling or judgment. Okay, so that's the difference between quantitative and qualitative. So the quantitative, the keyword is quantify, yeah, you can measure, and then for the qualitative, the keyword is qualify, yeah, or quality. All right, so you want to focus on how and why. So normally the student, when you start your research, yeah, your postgraduate research, okay, so the first thing that you need to do is you need to propose, isn't it? You need to propose your study, or you need to determine the best title for your research. And then, so to propose, you need to find the issues here. If you couldn't find the issue, then you don't have a good title. So there are three main things that you need to prepare. First of all, you need to define. Okay, define the focus of your study, the area of your study. So normally it involves a lot of literatures hunting. Okay, literatures hunting, such as you need to find lots of reviews article, okay, review studies, or maybe comparison studies, okay, and then you need to find out what are the current issues for the, for that particular topic, okay, and then you also need to find the new findings from the previous studies or maybe ongoing studies, okay, right. So the literature huntings can help you in determine where to start, okay, or to determine or to find out the loopholes on the issues or on the topic that you are going to investigate or you want to study. All right. So from the literature huntings, from the reviews, from the comparison studies, the current issues and the new findings from the published articles or reports, okay, you can actually come up with your own research questions for your research. Yeah, your own research questions. All right. So you need to find out what is the significance of your study. Okay, so from the research questions and the significance of your study, then you can come out, you can list out your objectives, okay, your objectives. So this is the good things about writing your objectives. If you are very clear of what you are going to do for your postgraduate studies, you will be able to write your objectives in a good flow. Okay, the first objective, the second, and then you can come up with the second objective, and then after you solve the second objective, then you go to the next objective, the third objectives. I'm not sure about the number in terms of the number of objectives for the postgraduate studies, but normally for the master studies we have at least 3 or 4 objectives, and then for the PhD studies, then we have maybe 5 at least or more. Okay, so it depends on the university and it depends on the discipline. Okay, so after you define your topic, you define your scope of study and everything, right? Then you need to identify. Okay, you need to identify what are the tools that you need to use. Okay, the instruments for measurements, and then how are you going to collect your data. So when it comes to the tools and instruments, so if you are doing a lab experiment, then you need to find out whether you have the equipment or not. Okay, so let's say if you are doing something to do with survey analysis, then you need to develop maybe, okay, you need to develop your instruments. So when I'm talking about instrument in survey study, I'm referring to a questionnaire. So it can be a standard questionnaire. It means that it has been proven, validate by the other or previous researchers, okay, from the previous studies, all right? So, or maybe you need to come up with a new instrument. Okay, so normally a new instrument is needed if you are doing PhD, yeah, Doctor of Philosophy. For the Master Science, you can use the standard questionnaire, all right, but you perform the survey study on a bigger group, okay, on bigger group, okay. So when it comes to identify the tools, instrument for measurement and data collection, there are a few things that you need to be clear about, okay. First of all, what is your population? Okay, what is your population? So that is actually to help you on helping you in determine your target group, you know, your target group. All right. So from the populations, then you need to determine on how are you going to collect your sample, choose your sample, draw your sample from the populations, and then what type of data that you are going to collect. And then you need to know what are the scales of measurements involved in your study, and then what are the variables that you are going to measure. Okay, so these are among the important things. Okay, the main things that you need to know. You need to know before you can proceed with the next step. Okay, before you can proceed with the next step. So after you are very clear about your populations, your samples, your scale of measurement, your variables, then you can choose your statistical methods. Okay, you can choose your statistical methods. So there are lots of statistical methods. Okay, there are lots of them, and then you maybe can actually categorize your statistical methods into two groups. Yeah, parametric methods or the non-parametric methods. So in order to determine whether you should use which one that you should use, then the second step just now, the identifications of the tools, instruments, population samples, and everything, and so on. Okay, if you can identify all these things, right, then you can end up with the most or the best statistical method for your data. So you need to know, okay, the relationship between the type of data, the scale of measurement with the statistical method. So you need to know how to link them. Okay, you need to know how to choose your statistical method based on your data characteristic, based on your data characteristic. So normally, students having problem with the third step, to choose. Okay, maybe they already collected their data. Okay, and then once they have all their data, but they don't know how to begin. Yeah, they don't know how to start analyzing their data. Okay, so they blur. Okay, and then so the objective, the first step just now can help you. If you write your objective properly, so each objective can be answered by certain statistical methods or tests. Okay, so normally it will start with a basic analysis for the first objective. Maybe you will start with the exploratory data analysis. So normally we have for the exploratory data analysis, you just need to describe your data statistically, maybe mean, mode, median, or maybe you just need your frequency tables or the graphical analysis. Yeah, but maybe you just need percentages. Okay, maybe you just need your cross step, and then followed by the second objective. Maybe you can start with a basic inferential statistics. Okay, basic inferential statistics, such as maybe you want to assess the distributions of your data. Why do you need to know the distributions of your data? Because it will tell you whether you can either adopt the parametric statistical method or the non-parametric method. So for the first group, to define all these things, I won't touch in details. Okay, so this one, I guess you can do it with your supervisors, and then you should know before you start collecting your data. So for today's talk, I will focus on the identifications. Okay, identifications of data collection, the method for the data collections, the scale of measurements, the variables, and how this information can lead you to the best statistical method. So it gives you some ideas, okay? Some ideas which test that you can try first, okay? And then you can get a preliminary results. And then after that, you can decide what is the next step, all right, for your data analysis. Right, so I touched about the three main things just now: to define, yeah, and then to identify, and then to choose the statistical method. Okay, all these things actually can be break up into smaller parts or smaller topics. So, and then it represent your design of experiment, or DOE. Okay, we have DOE here, design of experiment. This is actually the most important things before you start collecting your data. Okay, this is the most important step. Okay, so as you can see just now, you need to define your problems. Okay, so that's the reason why I stated just now, you need to find out your research questions. You need to come up with your own research questions. How can you come up with a good research questions? From your literature huntings, yeah, from your literature reviews, right? So if you can get a good articles, then you can actually a good review articles, yeah, review articles, then you can have some sort of ideas, okay, the directions of your study, yeah, the direction of your study. So if you are able to define the problems, if you are able to find the loopholes, okay, on your study area, okay, then you can determine your objectives. You need to define the problem first, right? If you cannot define your problems, you cannot come up with a good objectives, okay, with good objectives. After you determine your objective, then you need brainstorming, okay, you need brainstorming. Means that you need to brainstorm maybe with your supervisor, with your co-supervisor, or maybe with your friends, or maybe with the previous, with the other researchers who did the same, similar research, okay? Or maybe you can have brainstorming with the expert in that particular field, okay, to get additional inputs, okay, to get additional inputs, and then you can start design your experiment. It means that if you are doing lab experiments, maybe you can decide the material, the chemical materials, or maybe you can decide what is the best equipment. Do you have the equipments or not? Or do you need to buy the equipments or rent the equipments? Or maybe you need to borrow or asking permission from other university, okay, to use their equipments. Maybe your university doesn't have it, so you need to do something about it if you want to do that particular topic, and then that research need that particular instrument. Then you need to decide here how to solve it, yeah, the problem, how to start. Okay, so when it comes to the design experiment, you need this is the step where you need to identify your populations. Okay, this is the step where you need to define your samples, and then this is the step where you need to know whether you are going to do independent studies or longitudinal study, or maybe you are whether you need to use a time series analysis, or maybe you need to do something to do with the multivariate methods. Okay, so all this can be answered if you prepare your design experiment. Yeah, you design your experiment. Then after that, you can conduct your experiment. Okay, after you design your experiment, then you can conduct your experiment. So 1, 2, 3, 4, 5, all these 5 steps, okay, you need to do it after you identify all the samples, the data, and everything. Yeah, so remember the second step just now, we have defined, we have identified. So the design experiment and the conducting experiment belong to the second step just now, identification. Okay, identification. So once you start collecting your data, you already on the third phase. Yeah, on the third phase. Okay, it means that you already know what type of statistical analysis that you are going to do. Okay, then you can start do your data collection. Okay, do not collect your data until you are very clear about the potential statistical methods that you can use. Yeah. So do not collect and data. You do your data collection, then you think about the statistical method. That will be it will be dangerous. It will be very, very dangerous, because you will end up with you try to fit in whatever you have. Okay, maybe you need to change your title. So to make the data that you have already collected to fit in with the titles. So you need to work backwards. Okay, so this is not good. Okay, this is not good. You need to revamp your objective. You need to revamp your research question and everything if you do like that. Okay, so after you collected your data, then you will do the data entry. Sometimes maybe you collect your data, you use your log sheet, okay, log sheet, or maybe the questionnaires, all right, or maybe the Google Forms or whatever, all right. So you need to record your data properly, okay, maybe in Excel, maybe in any type of data files, or maybe you need to record your data in arrays or matrices, okay, depending on the statistical package or whatever package that you are available or you are very familiar with, okay, in order to analyze your data. Okay, after you completed recording your data, then you can start analyze your data. But this is not that simple actually, because if you key in or you record your data wrongly, then even though you still can analyze your data. Definitely you can analyze your data. But if the data file is poorly managed or structured or developed, then it will be a garbage in, garbage out. Garbage in, garbage out. Okay, because sometimes to analyze your data, it depends on the characteristic, the attributes of the data itself. So different type of sample has different way on how you should key in your data in statistical package. Okay, so for if you use Excel, the way you key in your data in Excel and the way you key in your data, let's say SPSS, okay, Statistical Package Programming for Social Science, all right, it's different. Okay, especially in terms of the rows and the columns, they are totally different. Okay, totally different, because Excel is more on worksheet. Yeah, so SPSS is something different. Okay, you cannot do the command and everything using the cases. No, cannot. Right? So there are different kinds of ways on how you can enter your data or record your data before you can analyze your data. It depends on the statistical package that you are going to use. Okay, and then after you analyze your data, then you can start interpret your results. But to have the output, it can be a good thing, it can be a bad thing. It depends on the data entry. It depends on the data entry. Okay, so you need to learn on how to interpret your results, your analysis results. So the knowledge on basic statistics, the knowledge on basic probability, okay, probability concept is important. Is important because this is the best way on how you can interpret your analysis results correctly. Okay, so you need this probability concept. Okay, you need to understand the meanings of the significant values, the p values, and then you need to know at least the basic on the hypothesis testings, what the difference between the null hypothesis statement, what is the alternative hypothesis statement, what is type 1 error, what is type 2 error, what happens if I do multiple comparison, it will increase the type 1 error, so how can I maintain or how can I control the type 1 error, and at the same time you can also control the type 2 error. So all these things, all right, all these things is needed, yeah, the knowledge on the basic statistics. So you need, regardless of your background, regardless of your backgrounds, because when it comes to the hypothesis testing, so it means that you need to know how to write your hypothesis statement, isn't it? All right, so you need to know how to write your hypothesis statement. So how can you write your null hypothesis the right way? Okay, so if your null hypothesis is like this, then how should I write my alternative hypothesis? So there is a different things between rejecting and do not reject the null hypothesis. So the most common mistake, for example, if you have a significant result in your data analysis, then you say, oh, I can reject the null hypothesis because I have enough or sufficient statistical evidence, or sometimes maybe you don't have significant results. So you say that, oh, I don't have significant result, I cannot reject the null hypothesis, so the null hypothesis accepted. So this is the most common mistake done by the students. Yeah, accepted the null hypothesis. You cannot accept the null hypothesis. You can accept the alternative hypothesis, but you just retain your null hypothesis. This is the concept. Okay, the jargons, the statistical jargons and terms, yeah, you need to be very familiar with in order to interpret your results correctly. Right, so you do need all these basics. So if you forgot about your statistics, so there's no harm. Okay, nothing to lose. Just go back and open your statistic books, the basic statistic books, and then try to start from scratch. Right, after you interpret your result, then you can do some verification. Okay, you can do some verification. So normally, let's say if you are doing modeling, okay, mathematical modeling or statistical modeling, maybe you need to identify whether the model that you obtain is the best model, to say, or maybe sufficient model. There is a difference between sufficient model and the best model. Okay, so you need different kind of analysis to reconfirm. Okay, you need to support your model with certain statistics. Okay, maybe using MAPE. Okay, any errors. Okay, any measurements on errors. So to see whether your model is a sufficient model, or maybe you can compare the errors, the different kind of errors measurements to find out whether the model is the best model. Okay, right. So these are 1, 2, 3, 4, 5. So we have 10 steps on design of experiment. Regardless of your field, regardless of your topic, at least you must have this. Yeah, you must have this. Okay, you can actually go more detailed. Okay, you can break up maybe the brainstorming. You can have sub steps, sub phases on that. So we have 10 phases here, or 10 steps, right, that you need to fulfill. Okay, so that you can have a good research. Okay, a good research. Now, just now when we talk about the identifications, okay, when we talk about identification, so I did mention about the population versus sample, right? So this is the first concept that you must know. Okay, what is the difference between population and sample? The easiest way to differentiate between these two, yeah, population is a bigger set, sample is a smaller set, and sample must come from the population. Okay, a subset. Okay, the population, when we talk about the entire group, a complete set. Okay, the sample is a subset of a population, right? And then so we have characteristic for the population. We also have characteristic or attribute for our samples. So you must know these two terms. Okay, parameters versus statistic. I'm not talking about statistics with S. Yeah. So because statistic can actually means two things. Okay, the disciplines in mathematics and the estimation value. So statistic actually carries two meaning. Okay, statistic, the field of discipline, one of the topic under mathematics, but actually it can stand in on its own, right? And then the second meaning is the estimation value, right? It is also known as statistics. So when we talk about the mean, the percentages, the median from the population, it means that we are talking about parameters. Okay, let's say if I give you the standard deviations of the population, let's say we are talking about CGPA, students CGPA, okay, for university, one university. So the average of the CGPA for the maybe the faculties under any university, so that is considered or called, that is known as parameter, okay, population mean. But when we are talking about sample mean, so the sample mean is one of the example of a statistic. Okay, so parameter and statistic. So parameter referring to any characteristic from population, and then statistic referring to characteristic of sample. All right, so the population and the sample. But then normally people will ask, how will I know that I'm having a good, I can get a good sample? How do I know that my sample is a good one? So what you need to describe, you need to explain what good is. Okay, what good is. So in order to have a good samples, okay, you need to ask yourself, what are the data collection methods that you are going to adopt? Okay, let's say for the lab experiments, maybe you need to be able to define your experimental units. So you need to know what your sample units are. So you need to know what's the difference between experimental units and sample units. Okay, you need to know what is the difference between experimental units and sample units. And you must have a control. You must have a control. And then you need to know what your treatments are. Okay, so how many treatments and which treatments will can be considered as a control, something like that, right? So this is something to do with the lab experiments, that all these things you need to be able to explain, all right? So let's say if you are doing a survey study, so maybe you are going to use questionnaires. The questionnaires may be a standard questionnaires, right? So you don't have to do anything. You just use a standard questionnaire, so you can save yourself from the needs to justify whether the questionnaire is a good one to measure what it's supposed to measure. Okay, or maybe you are going to collect your data by phone calls or emails, or maybe Google Forms. Okay, so Google Form is the currently among the most popular one, especially during PKP. Okay, it's difficult for you to go and then find your respondent face to face. So most of the students tend to use Google Forms to collect your data, their data. Now, and then let's say if your research involves fieldwork, okay, maybe you from forestry background or geology background, biology background, environmental study maybe. Miss Salwa from environmental study, and maybe you are marine student or aquaculture. So you still need to know what your experimental units are, what are the sample units, or maybe you need to do transect, who knows, yeah? So you need to determine the size of your transect, something like that, right? The distance from one point to one point. So all these need to be identified and determined before you can start collecting your data. Or maybe you don't really need to collect your data. You just have to use secondary data from the data bank or from any official websites, all right? So you can also analyze your data using secondary data, all right? Or maybe you can get the data from any industry, okay, maybe from factory, yeah, from factories, or maybe from bank, yeah. When I said bank, I mean the financial banks, okay? Maybe you are doing about default studies, or maybe you are doing MCDM, multiple criteria decision making, right? For the clients, for the any banks, customers, something like that. So this type of study using secondary data. Okay, but what you need to know, samples, your sample must represent your population well. Okay, the sample must represent the population well, because we cannot take the, or you cannot measure. It's very difficult to measure every single element or subject in the population, especially if you have a big population. So you have lots of difficulties that maybe you need more budget, okay, fund, yeah, maybe you need more time, maybe you don't have much time, maybe you only have 2 years or up to 3 years, right, to finish up your research, okay. So that is the reason why we do sampling, sorry, okay. So in order to represent the population well, then you need to draw your sample from the population using certain sampling method. Okay, so how to do that? So how to get a good sample from the population? So it depends on the sampling methods. Okay, so when it comes to the sampling methods, we have actually 2 categories. Okay, the first sampling method is known as probabilistic sampling. Okay, so the other one, the probabilistic sampling, the most common and the basic sampling method is the simple random sampling. Okay, so the keywords here is random. Okay, random. So it's kind of difficult actually. Some of the researchers, they don't really have a good understanding on what random mean. Okay, what random means. So the easiest way to understand the terms random is every subject or every element in your population has the chances or the possibility or the probability to be selected in your sampling. It means that, let's say, if your population size is 1,000, every single subject, okay, in the population, the 1,000 subject, all of them has the chances to respond, okay, to be involved, okay, to be selected, okay, in the sampling, right? That's what random means, okay? That's what random means, all right? That is simple random sampling. Okay, let's say if you have 1,000, if the population size is 1,000, it means that the probability of one subject to be selected is 1/1,000. So all of the subject has equal chances to be selected. So this is what it means by simple random sampling. And then we go to the second basic sampling method, which is known as cluster random sampling. Okay, cluster random sampling. So cluster means group. Okay, so normally when it comes to group, the subject has heterogeneous background. Heterogeneous background means that varies, right? But they can be cluster based on the maybe location, certain physical group, let's say in the same building, the same floor, okay, or geography, based on the geographical locations, let's say the states, the area, okay. So for the cluster random sampling, the clusters, the group is the groups are chosen randomly. It means that every state has the same chances to be selected. That is cluster random sampling. Okay, and then once, let's say if we have 13 states, and then we choose randomly 3 states, and then let's say Sabah, and then Perak, and then Malacca have been selected. Okay, using the cluster random sampling method. Then you need to collect your data on every single subject in Sabah, in Malacca, okay, in Perak. okay, which is quite difficult, isn't it? Yeah. So let's say if you want to perform or carry out your study, let's say in one faculty. Okay, one faculty, let's say for the Faculty of Science and Natural Resources in University of Malaysia Sabah, we have about, if I'm not mistaken, 11 programs. Okay, 11 programs, and then each program can be treated as clusters. Yeah, clusters. And then the background is considered as heterogeneous because we have first year, second year, third year, final years. Okay, they are taking different subjects. So these actually can be identified as heterogeneous, right? All right, and then we have stratified random sampling, stratified from the keyword strata. Okay, what's the difference between cluster and strata? The strata has a homogeneous background. So they share the same backgrounds. For example, maybe the best representations of strata is the batch. Let's say if for the mathematics with economics students, we can actually stratify the students based on their year. Yeah, the first year, the second year, the third year, and the fourth year. Because these students have this homogeneous background because they are taking the same subject, something like that. Okay, so that's the difference between cluster and stratified. And then for the systematic random sampling, this is good because maybe for sometimes even for those who are doing field work, I think systematic random sampling is one of the popular options. Okay, for your sampling methods, right? So let's say if you are marine researchers, okay, if you want to take your data, let's say certain areas, okay, maybe you can choose one island, all right, and then maybe you want to measure the corals, maybe the quality of the corals or whatever the attributes relating to the corals, yeah, distributions, right? You can actually have your own transects, yeah, you can have a transects, and then you need to have a systematic distance from the first point, yeah, the first point. But remember one thing, this is the most common mistake done by researcher. Even though it says that systematic random sampling, but the first point must be determined randomly as well. It means that you cannot decide, oh, this is the first point, and then we will have our transect for every, let's say, for every 5 meters. Okay, for every 5 meters. No, you cannot simply fix your first point. The first point may be, since that you are doing every 5 meters, then you need to choose the 1, 2, 3, 4, 5 meters. You need to choose randomly. You can use the random table. You can use also the random random numbers operators, maybe using any statistical packages, right? Or maybe we have random number calculator online, right? So let's say out of 5, 3 has been selected as the random number. So you need to measure from the beach, maybe, okay, 3 meters from the beach, and then that will be your first point. Then you can start every 5 meters and onwards, right? Okay, this is the mistake always done by the researcher. The starting point need to be chosen randomly as well before you can start with the systematic random sampling. So another basic sampling method is multi-phases random sampling. So the multi-phases random sampling is a combination of the 4 sampling methods. Okay, the simple, cluster, stratified, systematic. For example, let's say you already stratified your population, and then you already choose your strata randomly, and then from each strata you conduct a simple random sampling. So you have 3 phases random sampling. The first one is the cluster random the stratified random sampling, and then within the strata you perform the simple random sampling. So it is also one of the example of multi-phases random sampling. You can have actually not only 2 levels, you can have 3, 4, okay, levels of random multi-phases random sampling, right? So these are the basic sampling method under probabilistic sampling. So another one is known as non-probabilistic sampling. Okay, so something to do with convenience sampling or selective sampling, etc. Normally done by the expert of that field, okay, of that discipline. For example, if you are collecting data in, let's say, in a forest, okay, so maybe you try to find certain species, right? So let's say Imbak Canyon, yeah. So I guess maybe some of you already been to Imbak Canyon in Sabah, okay, or maybe Maliau Basin, all right, or maybe Kinabalupa, right? So the convenience sampling or the selective sampling done by the rangers. Why? Why the forest rangers? Because they actually have the experience. They know which area has that certain species that you are interested on to study. Okay, so the sampling done conveniently by the expert. Okay, selectively by the expert. Okay, so it means, so what is the difference between these two, probabilistic and non-probabilistic? Normally for the probabilistic, we can do the modeling. We can actually do the generalization. But unlike the non-probabilistic sampling, because we cannot actually force probability values, okay, from that type of samples, okay, from that type of samples. So we just, this is similar to, this is more on to study the to study the, let's say for just now the example, the species, right? So you just want to know more about the distributions of that particular species for that certain area. Okay, but for the probabilistic sampling, normally you will end up with estimating something. You will end up with predicting something. Yeah, predicting something. So, and then maybe you will end up with a certain mathematical model so that you can estimate, you can predict. So these things need this type of sampling methods. All right.
We have three questions from the audience.
Oh, sorry, I didn't see it.
Oh, okay. So I will read it. Question from Zahid. In your example, it will be multi-stage sampling, right?
Yes.
So the choice of states in Malaysia and the choice of respondent in each state, will these two stages of sampling share the same sampling method?
Oh, sorry, again. I didn't get you.
Okay, Doctor. If we choose of states in Malaysia and choose of respondent in each state, so will these two stages of sampling share the same methods, sampling method?
Okay. You can choose the from the 4 basic sampling methods just now. So the stage, the state can be the cluster. Remember the cluster sampling methods because they have heterogeneous background. Okay, it depends on the focus of your study. What are you going to find out? Okay, what are you going to find out? Let's say we are in the middle of COVID-19 issues here, right? So let's say if you want to do the, if you want to study the distributions of the positive cases throughout the countries, right? So for the COVID-19, we have green areas, we have red areas, isn't it? Okay, we have green areas, red areas. So you can also cluster your sample based on these colors. Yeah, the green, the red, right? Maybe the orange. I think we have 3 colors, right? Red, orange, and green, right? Or is it yellow? I'm not. I don't remember. Right.
Yellow,
So,
yellow.
is it yellow?
Yellow. Yes.
All right. So, you can choose, because we have more than one green areas. We also have more than one red areas, isn't it? So Tawau in Sabah is also used to be one of the red areas. So sometimes you cannot actually select all the red areas in Malaysia or all the green areas. So you can list out all the green areas, you can list out all the red areas, and then let's say you need to select two red areas and two green areas randomly. So you need to conduct, you need to conduct random number selections, okay? And you need to key in the areas, and then you need to use the package to select the area randomly for you, and then you just focus on that area, the selected area for your study. All right, so you already done the cluster sampling, and then let's say the green area, we have a town, maybe a few towns under the green area. For Kota Kinabalu, it has been declared as red area once, and then in Kota Kinabalu we have Penampang, we have Tuaran, we have Putatan, right? So you can also run the second stage of random sampling. So maybe you cannot cover all the areas, okay? For that green green areas, you cannot go for every town. So you can choose randomly again, right? So it depends on the it depends on you, what you are going to answer, what you are going to find out, what you are going to investigate, and then do you have enough fund to do your analysis. That is why I have my slide here, the sample size. Okay, the first point that I would like to stress is the notions of the bigger the better. So when my student asks me, so how big my sample should be, how many respondents should I have, or how many times I need to repeat my treatments, so my simple answer will be the bigger the better. The bigger the better. Why? Because better insight that you can obtain from your data if you have more data. Okay, you have more data, it means that you have better insight. More data means more statistical evidence. That's why we have the notions, the bigger, the better. Yes, it is, you can actually do multi-stages. So the example just now, the previous example on the state just now, we have 2 stages. Yeah, we have 2 stages. But if you want to narrow down your study, you want to investigate further, then you might end up with 3 stages of random sampling or 4 stages of random sampling. Is it clear or not?
Okay, Zahid, is it clear? Okay, Doctor, another question from Jaya.
Yes.
If we want to collect survey data from deans and top management of private university, which sampling method is the best way to use?
Okay. So I go back to the objective just now. When you say that the top management, so normally when it comes to the top management in the university, do you need sampling? Because there are not so many of them. Because there are not many of them, all right? So let's say if the top officers in one university or management, how many of them? Maybe 10, maybe 20, not many, isn't it? So still the first notion, the bigger the better. So you can actually ask all of them, but not all of them will respond, isn't it? Okay, let's say if we have 30 top management staff, okay, so you invite them, every single one of them, to participate in your study. Let's say out of 30, only 15 of them replied or responded. Okay, that is good enough because you have 50% of the population. Your population is all the top management staff, right? So out of 30, you have 15. It means that you cover 50% of your population. Remember, the rule of thumb for the sample size is 20% of the population size. Right? So if you have a small population, so it's easier to fulfill this rule of thumb. But remember one thing, if you have a population that go for all of them, right? So let's say if out of 30, only 25 responded, that is good enough already. That is good enough already. You already fulfill the requirement of the random sampling. Why? Because all of them has the chance to participate in your study. All of them receive your questionnaire or your Google form, all right? But whether they want to respond to your questionnaires, your requests, then it's up to them. Okay, it's up to them. They already have the chances, but you already fulfill the random sampling requirement. Is it clear or not, Jaya? Is it?
Question from Jaya just now.
Yeah. Is it clear or not, Jaya?
Yes, clear. Yes, clear.
Okay, thank you, Jaya.
Question, is sample is equal to target population?
No. No. Sample is not target population, but it's a target group. Yeah. So let's say my target is university students in Malaysia. That is my population. All the university students will be my population. But of course, I cannot involve every single one of them in my analysis, isn't it? Right? So maybe I will end up, let's say if we have 30 universities, but I can only collect data from 3 universities out of 30 universities in Malaysia. But I also cannot get a respondent from the university, 100% of the student from that particular university. So I need to narrow down my study. Okay, let's go for final year students only, for this faculty only, for this program only. Yeah, so that is the reason why when you do your design of experiment, okay, remember just now the first 5 steps, okay, under your design of experiment, you need to decide you need to design your experiment. You need to design your experiment. When it says design your experiment, you need to narrow down your focus, the focus of your study. Why? Because it helps you to identify the population and then to identify your target group. Okay, the target group, the target population and the target group. Is it clear or not?
Okay, thank you, Dr. Clear explanation.
Okay, thank you.
Okay, Doctor, maybe this is the last question from the audience so that Doctor can continue to present the slide.
Yes.
Next question. Okay, if I use secondary data from my research and my study is on selected list firm for 10 different countries, which sample method is the best way to use?
Firms, isn't it? Companies, isn't it? From 10 different countries.
Yes.
It means that the countries are already been selected, isn't it? You don't have to sample them.
Nur Akila, maybe you can answer. Oh yes, doctor.
Already been selected, isn't it?
Yes, she said.
Okay, so you need to identify which type of firms that you are going to study. What type of firms? So you need to narrow down the type of firms. And then let's say for Malaysia, let's say we have 100 firms fulfill your requirements. All right. So you can do the simple random sampling. How? By inviting the firms to participate. Inviting the firms. Maybe out of 100, only 10 of them willing to participate. It doesn't matter because you already fulfill the requirement of the random sampling. Do you understand? Okay. So, but for the 10, that is not enough actually. When it comes to, let's say you have 10 countries, at least you must have 30 from each country. 30 firms, all right? So it depends on whether the target group, the target populations is big or not. So some of the population is known as finite population. And then we also have infinite populations. Finite population means that you can count. Yeah, you know exactly the number, the size of the populations. For the infinite population, you don't really know the size of the population. It's too big maybe, okay, or you don't have the data. So that's the reason why the central tendency theorem in statistics plays a big role, okay, big role in justifying, so as a justification to support your sample size, whether it is actually sufficient to give you evidence, statistical evidence or not. So we always play with the number 30. Okay, so the basic statistic books always say 30, 30, 30. I hope you all remember, isn't it? So bigger, the better. Okay, is it clear?
Okay, Dr. Clear. Clear,
Okay,
Dr.
thank you.
Okay, Dr. So maybe Dr. can continue to present the slide.
Alright. Okay, so many of you asking about sample size, isn't it? Just on time, because I just on my next slide on sample size. Always the notion for the sample size is the bigger the better. There are many reasons why you need to have a good size for your sample. One of the reason is, let's say but some of the sampling method we very expensive. One of the some of the data collection processes involve a lot of the cost may be very big. So you cannot you cannot have a big sample size for maybe the experiment is too expensive. All right. So when you have this kind of problem, okay, you must make sure that you do replicates. Okay, this is another terms that you must remember, replicates, all right? So at least 5 replicates for the same treatment, okay, for the same situation, at least 5 replicates. The reason why, because in parametric method, the assumption on the normality distribution plays very important roles, okay, because if your data doesn't follow the normal distributions, then even though you have a significant analysis result, the result is questionable. Why? Because it doesn't fulfill that, your data doesn't fulfill the assumptions for that particular analysis. This is actually a drawback, a setback actually for your findings, right? So you must have at least 5 observations for the same cases, because if your data doesn't follow normal distribution, then you can go for the non-parametric methods. Okay, the problem in non-parametric method, let's say if you cannot do your ANOVA because the normality assumption has been violated by your data. So maybe you go for the non-parametric alternative, let's say Kruskal-Wallis. Yeah, the things about the non-parametric method, especially for the Kruskal-Wallis, you must have minimum 5 observation for the same case, 5 observation for the same group. If you have less than 5, you cannot perform the Kruskal-Wallis. Then you cannot perform the alternative option, the alternative test, statistical test for the ANOVA. So it will be, you will end up nowhere. Okay, so that is why the DOE is very important when you design your experiment. Okay, when you design your experiment. So the notions of the bigger the better always plays important role in sample size. Okay, so if you have a bigger sample size, then it gives you enough or sufficient statistical evidence. And then the reason why, because when I said statistical evidence, we are dealing with probability values. Okay, so the significant values, the p-value in any statistical test heavily rely on sample size. Okay, you can have, let's say, if you are studying about correlations, you can have a very strong correlation coefficient for variable A and B, let's say. But when you look at the p-value shows insignificant result. But the coefficient is very strong. It's nearly 1, let's say 0.8. But why the p-value is greater than alpha, 0.05? It means that there is no genuine linear association between these two, even though the coefficient is very high. The reason is because the n is small. Insufficient statistical evidence. The correlation coefficient close to 1 is only by chance. It is not a genuine linear association. Okay, I don't want you to have this kind of problem. Okay, so we need to have a bigger sample size. Always have bigger sample size. The bigger, the better. So how to estimate the sample size? The sample size. As I said just now, we have the rule of thumb for the sample size, but the rule of thumb only applicable for a finite population. It means that when you know exactly the population size. But there is a problem when you don't have the information on the population size. All right. So normally, okay, this is where the literature hunting plays an important role. Okay, you can justify your sample size based on the priori assumptions from the previous studies. Let's say you have 10 articles from the 10 different research, but similar on the same on similar subject, right? And then maybe one of the article use 30, the sample size equal to 30. One of the articles has sample size equal to 100. So which one that I should follow? The 30 or the 100 or maybe the 25? Okay, you choose the articles or the previous work which is very close to what you are doing. Very close to what you are doing. And if possible, have slightly larger sample size compared to the previous one. Yeah, because you need to have some added value, isn't it? Okay, if the previous one has sample size 100, maybe you can have 150 or 120. Okay, this always works for the infinite population size. Or you can also estimate your sample size based on equations or formulas. Okay, equation and formula. So we have quite a number of formulas to determine the sample size. But I will give you the most basic one here. Okay, so these are the most basic formula for the sample size, but it's actually corresponding to the type of the data and the type of the samples. Okay, for example, if you have continuous outcome, when I say continuous outcome, something that you can measure, you can count, okay? And then let's say if you have one sample, so this is the most common one, okay? And then if you have continuous outcome as well, and then there are 2 independent samples, then this is the best one. Okay, this is the best one. Okay, remember NI, whenever I have this one, whenever I have 2 independent sample, I will use the subscript I, all right? Because this is how we can determine the first sample size and the second sample size, right? So let's say if you have another continuous outcome, but this time the samples are dependent, then this will be the one of the basic formula to determine your sample size. All right. So E stand for error. Okay, E stand for error. So you, the researcher, need to predetermine the error, the maximum error that you can be allowed to commit. Okay, to commit. So it depends, maybe 5%, maybe 10%. It depends on your discipline. Okay, normally for the science research, sciences background, okay, we have very small error compared to the social science studies. Okay, compared to the social studies or the social science or social studies, right? But for the lab experiment, or especially for the pharmaceutical study, chemical study, right? We tend to have very small error. Okay, so let's say if you have dichotomous outcomes. So this is the things, the jargons that you need to understand. Dichotomous, yeah, dichotomous means we have two binary, okay, outcome, and then from one sample. So this is the basic formula to determine your sample size. Right, so this is related to the proportions, or I can also say that it's related to the binomial probability distribution. Okay, so you can use this formula, and then we have also another dichotomous outcome, but from two independent samples. So this is the most common formula that you can use to determine our sample size. Actually, if you Google it, we have sample size calculator. Yeah, sample size calculator, but you need to understand what to put in, the information that you need to put in order to generate the sample size, yeah, from the calculator. So these are the basic formulas for it. So the thing is, since that we have here continuous outcome, then you need to know what it means by continuous, dichotomous. This is something to do with the type of data, the type of the scale or the level of measurement. And then I mentioned here independent, dependent. Then you need to know how to distinguish between independent samples and dependent samples, because this is very important. Yeah. Whether your data is independence or dependence, whether your data is continuous or dichotomous or categories or in frequencies, these are the important information that you need to know before you can decide your statistical methods. Okay, before you can decide your statistical method. That's the reason why my slide here explain a bit on the samples. Okay. So the difference between independent sample and dependent samples, okay? Independent sample, dependent sample, okay, another name for dependent sample is match samples or paired samples. Okay, we have three names for the dependent sample: dependent, match, or paired. Okay, so for the independent samples, measurements made on two or more different sets of items or subjects. Also, it means that no overlapping. In other words, that one items can only belong to one and only one group. Okay, one items or one subjects or one entity can only belong to one and only one group. Unlike the dependent or match or paired, okay, measurement made on the same item or subject at two or maybe more than two different time points. Okay, time points, right? Or maybe different treatments. Okay, treatments, yeah. All right, so for the dependent or match or paired, you actually measured the same group of subject, measured the same group of items a few times. Okay, a few times. If you are talking about since that you need to know, you need to have a homogeneous background for your respondent. Let's say, so you if you are tasting, let's say, certain drug, okay, certain drugs. So before you can measure the same subject at the second time point, you need to have a flashing time means that the effect of the first treatment has been flushed out. Okay, maybe it needs 2 weeks, 3 weeks, then you can start with a new treatment. Okay, or the second drugs. Okay, you want to compare them. All right. So means that you measured the same subject, the same item, the same group a few times, right? So these all normally involve in pre and post study, before and after, or maybe if I want to compare the air quality, okay, last year 2019 and this year, because we have PKP, isn't it, the COVID-19, so we don't really have many vehicles on the road, and then not many flights, the whole world, yeah. So even if you Google, you can find one articles regarding the air quality in the Arctic areas, yeah, and then something to do with the big holes, black holes, and something like that. That you can find one article discuss about this, yeah, during the the COVID-19. During the COVID-19 problem, the whole world, the air quality increased drastically. You can find it, you can Google it, yeah. So if you want to measure the whole year, the entire years, 2019 and 2020 up to, so we have July, so from January to July 2019 and January to July 2020, then you can compare the air quality. Okay, let's say for Malaysia, we have, let's say, 100 stations. Okay, 100 station produce the whatever the pollutants measurement, all right, throughout Malaysia. Then we can compare the readings. Okay, station 1 until station 100, station 1 from station 100. Then we have two set of measurement from the same station. So this kind of design of experiment under dependent or match samples. Yeah. Why do we need to know this? Because different statistical methods need to be adopt or need to be carried out for this type of design of experiment. Yeah, you cannot simply choose, cannot. Yeah, you need to understand the samples. All right, when I said that for the dependent or match or paired samples, the measurement made on the same item, the same group, but it also can be done on different groups, as long as the groups has a homogeneous background. Okay, this is always done in education studies. Okay, when they try to compare maybe 3 different teaching style. Okay, so it's kind of difficult, because once you have learned one topic, you cannot test them again, because there will be the prior effect, isn't it? So what they can do is they can have, let's say, 2 groups with homogeneous background, and then they are given 2 different teaching styles. So how can we sure that these 2 groups came from homogeneous background? Maybe you can check the previous assessment. Yeah, only those who achieve B and above can be in both groups. Yeah, we try to minimize the variability. Yeah, to minimize the variability as low as possible, so that they will end up with homogeneous background. They have the homogeneous characteristics. So this is also done especially in education studies and psychological studies, right? So on dependent samples. So that's it. So you need to know whether your samples are independent or dependent. Not only to identify, to determine the best statistical method, it also plays an important role in how you should key in your data in your Excel, or in your whatever R, or maybe in your Minitab, or maybe in your SPSS. Because, for example, SPSS, the way you key in your independent sample and dependent samples are different. Totally different. Or let's say if you have your data in frequencies, the way you need to key in your data in frequencies in SPSS is also different from the independent sample and dependent samples, right? So you need to be aware of this. Now, when we talk about samples, do not confuse yourself with variables, because we have independent samples and dependent samples. We also have independent variables and dependent variables. So do not confuse yourself. So let's have a look at the definitions of the independent variables and dependent variables. For the independent variables, it says here the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variables. Okay, the independent variables sometimes is called predictors or factors. Yeah, predictors, factors also refers to the same type of variables, which is independent variables. Okay, normally the independent variables are the variables that you can fix, you can adjust. Yeah, you can fix, you can adjust, you can determine. All right, you can fix the values, you can adjust the values. For the dependent variables, this is the variable that you are interested on. Okay, that being tested and measured in a scientific experiment. Okay, so another name for the dependent is response variables. Okay, response variable, referring to dependent variables, response variables. So the dependent variables is called a dependent variable because it is dependent on the independent variables. Oh, that is quite confusing, isn't it? So the dependent variables, yeah, the response variables depends on the predictors, the independent variables. Yeah, I use predictors and response. So the response variables depends on the predictors, right? So as the experimenter, which is you, who changes the values of the independent variables, you will study the effect on the dependent variables. Okay, you will study the effects on the dependent variables. So normally, you need to know whether your variables are independent or dependent when you do your regression, when you do your modeling, because you need to know which variables affecting which variable. Okay, you can have more than one dependent variable. Yeah, so if you are talking about, if you are doing simple linear regression, of course you only have one dependent variable and one independent variable. When it comes to the multiple regression, so you have one dependent and then maybe two or more independent variables. But when you are talking about multivariate analysis, you can have more than one dependent variable as well as independent variables. So it's becoming more complicated, right? But you need to know which one is depending on which one, right? The question is, not the question, can dependent always be dependent variables? No. It depends on the focus of the study, because sometimes when you change your objective, when you change your aims, then the dependent can be an independent variables, then independent variables also can be a dependent variables. Yeah, it depends on the focus of the study, right? So when it comes to the correlation, let's say association test, it doesn't matter whether your sample, whether your variables are independent or not. Because when it comes to the association, we don't really need to know whether one variable affecting the other or the other way around, okay? Right, we just want to see the association, that's all. So it is not important to know which one is independent and dependent. Right, so now, when it comes to the variables, then you need to know the levels of measurement, the scale of measurement for your variables. So in statistics, we have 4 basic levels of measurement. We have ratio, we have interval, we have ordinal and nominal. This is important, especially when you're collecting your data, okay? For example, in survey analysis or in public health study, yeah, in public health, if we have public health student here or medical student among you, right? So normally for the public health and the survey, they tend to categorize the items in their questionnaires. Let's say the categories, the age categories, something like that, right? They try to categorize it to make the survey simpler. Okay, my advice to you is do not categorize anything. Okay, if you can have, let's say, CGPA or age, right, or the height or everything, something that you can measure in ratio and or in interval scale of measurement, let it be. If you want to categorize them, then categorize them later. Okay, but when in data collection, get the highest precision as possible. Okay, out of 4, the ratio level of measurement is the highest precision level. Nominal is the lowest. So when you collect your data, try to refrain yourself from categorizing the ratio or interval level of measurement. Okay, try not to categorize them at the early stage. Okay, so for the ratio, so what's the difference between these 4? The ratio, all of them are names. You can name the variables, right? For the ratio, you can order the values. Of course, 1 is lower than 2, 2 is lower than 3. That is a ratio, isn't it? And then it is proportionate intervals between variables. Yes, between 1 and 2, proportionate to 2 and 3, 3 and 4. Between 1 and 10, 10 and 20, we have a proportionate intervals. And then for the ratio, we have true 0. What does it mean by true 0? It means that 0 is an absent value. When I said that, how many cars do you have? 0. It means absent. It is a true 0. It means nothing, null. Okay? So for the interval, also share the same characteristic with the ratio level of measurement. Okay? It is also can be ordered. It is also proportionate intervals between the variables, but it depends on the instrument. Most of the time, the interval levels of measurement doesn't have true zeros. What does it mean by no true zeros? Let's say temperature. If I say the temperature is 0 degrees Celsius, it doesn't mean that we don't have the temperature. We do, but the value is 0 degrees Celsius or Fahrenheit, something like that. So it means no true zero. The temperature is there, it still exists, but the value is 0. So that's the difference between ratio and interval. And then for the ordinal, it is also can be ordered. We have the ranking, but we don't have a proportionate intervals between the variables. But it depends, yeah. It's because it's very subjective. So the some of the ordinal scale, we have a proportionate, but proportionate intervals. Some of the internal ordinal scale, we don't have a proportionate intervals. Okay, so for example, the Likert scale, 7-point Likert scale, or maybe the class of degrees, first class, second class, third class. Yeah. Why I said it is not proportionate? Because maybe the for the third class degree is from 2.0 to 3.0, isn't it? And then for the second class, the second class, okay, the second class between 3.01 until 3.5 or 3.49. So it is not proportionate already, the intervals. Maybe the first class is 3.7.5 or 3.51 up to 4.0, something like that. That's what it means by the in proportionate intervals between the variables. And then for the nominal, well, the keyword is nominal, name, okay? It has no magnitude. We only use it to categorize, for categorizing, for grouping. No magnitude, no, cannot be ordered. For example, female and male. Can you say that, oh, female is higher than male? No, it's only a group, yeah? It is only identifications of the for the categories, right? For example, the type of degree that you have, right? Or the faculty, okay? The name of the name of the faculties. So these are also considered as nominal levels of measurement. Now we end up with the statistical method. So after we go through the samples and everything, so how can we determine the best statistical methods for our data, for our study? So the main question here is, what is your aim? You need to ask yourself, what is your aim? So how do you know your aims? Go back and refer back your research questions. Go back to your objectives. So your objectives supposed to have the keywords. Okay, try to compare, try to estimate, try to find the association. Am I right? Okay, your objectives normally has the keywords, right? The keywords actually can determine the statistical methods that you can perform at the end of the of your study. Okay, right? So the aims. So you can ask yourself, are you trying to compare the samples or the groups, right? Or are you trying to see the relationship, the correlation or the association, right? Or maybe you try to estimate something, or maybe you try to come up with a certain model, mathematical model, so that you can forecast maybe, or you can estimate something. Or maybe your aims is you want to see the multiple variables, yeah, multiple variables at the same time, okay, the simultaneous effects of multiple variables, something like that. So you might end up with the multivariate analysis. So this is the main one, but not restricted to four stages, 4 types of statistical method. These are the main one. We can have more, but I don't want to touch more of that because it will be more complicated topics. Okay, these are the most common statistical method that postgraduate student use for their data analysis. Right. So you need to ask yourself. So you need to go back to your research questions. You need to go back to your objectives. Find the keywords. So if you can find the keywords, then you know where you should go. Down, to the left, to the right, or up. Okay. Now, let's say if you try to compare your samples. Okay. So I mentioned here comparison of means or medians or ranks. The reason why, because maybe your data normally distributed, or maybe your data is not doesn't follow normal distribution. So you will end up to there are two paths, parametric path or the non-parametric options. Right. So for the parametric options, for the parametric statistical methods, normally we use means, yeah, to represent the central tendency of our sample or groups. For the non-parametric one, normally we use medians or ranks. So you need to know whether you have the number of your samples, whether you have 2 samples or you have more than 2 samples. And then you need to know whether your samples are independent or dependent samples, because these 3 attributes, parametric, non-parametric, normally distributed, not normally distributed, 2 sample or more than 2 sample, independent or not independent or dependent sample. So all these 3 characteristics will determine the type of the statistical method when it comes to comparing the group, comparing the sample. Okay, so for example, if you have 2 samples only, and then the data follow normal distributions and both samples are independent, then you can proceed with the independent t-test. But if you have more than 2 samples and all of them follow normal distributions and all of them are independent from each other, then you can perform ANOVA, analysis of variance. Okay, but if the samples are dependent, then you have 2 samples, they are also normal, then you can perform match sample t-test or paired sample t-test or dependent sample t-test. Okay, the 3 names but refer to the same test, right? And then if you have more than 2 samples, then ANOVA for match or for dependent sample is the best option for you. Okay, it's the best option for you. Let's say the assumption, the normality assumption has been violated. Okay, you already increased your sample size, but it is still skewed, let's say. Okay, and then you can choose another option is by performing the non-parametric methods. Okay, the non-parametric method use medians or ranks. Okay, so if you want to compare two independent samples, then you can proceed with Mann-Whitney test or Wilcoxon rank sum test or median test. If you want to see whether is there any significant difference between the groups. Okay, but if you have more than 2 samples, then Kruskal-Wallis is the most popular one. Okay, this is the non-parametric option for the ANOVA. Okay, whenever the data does not, whenever the data violating the normal assumption. So if your samples are dependent and there are 2 of them, then you can perform maybe Wilcoxon sun rank test or the sign test or the Magnemar test. Okay, but if you have more than 2 samples, then you can proceed with fragment test or Kendall's W test or Cochrane's Q test. So the question is, which one is the best? Okay, you need to study. Okay, you need to study every single one of them and then try to find out which of the tests fit your data well. For example, between Mann-Whitney test and median test. Okay, median test is the simplest one and very lenient. Very lenient. Okay, but the Mann-Whitney test is stricter compared to the median test. Okay, so it's up to you. You can choose median test or Mann-Whitney test. Sometimes you can perform all the 3 tests under the same category, and then you can end up with the same result or you can end up with different results. Okay, so there are a lot of things that you can discuss on that, right? Because sometimes for the same purpose, if you perform 2 or 3 different methods, statistical method, you can either end up with the same result or with different result. It depends on the statistical method itself, because some of the statistical methods are stricter and then some of the statistical methods are more lenient. Okay. Now, this is the first aim if you try to compare the groups. Let's say if you want to look at the correlation of the or the associations of the variables. Okay, so here I give you 4 different tests. We have Pearson test, correlation test, we have Kendall correlation test, we have Spearman correlation test, and chi-square test. All right. So bear in mind, we have many association tests. These 4 tests only for the univariate. Okay, when we measure one variable at one time. Okay, right. So one variable for x-axis, one variable for y-axis, something like that. Okay, for the Pearson test, it is suitable for the interval or ratio level of measurement. See, you need to learn you need to know the level of measurement. Okay, interval or ratio level of measurement, and there is additional requirements. Yeah, the variable must follow the shape of the Gaussian distributions or normal distribution. Okay, so if they are in interval or ratio level and they follow normal distribution, then you can proceed with Pearson correlation test. But if, let's say, one of the variable is a binary variable and the other one is interval or ratio, you can also proceed with the Pearson correlation test. But given that the dichotomy variable has been coded as 0 and 1. So it means that if you code your binary variable as 1 and 2, then you cannot perform your Pearson test. It must be coded 0 and 1. Okay, that is the rule, right? So let's say you have the interval or ratio, but it doesn't follow normal distribution. Then you need to choose either Kendall or Spearman. Okay, so these 2 tests will treat the rankings. We'll use the ranking of the interval or ratio measurement instead of using the raw measurement itself. Okay, they will audit the measurement, and then they will rank the measurement, and then the test, the statistic of the candle test and the spearmint test based on the rankings of the raw data, the rankings of the raw data, not the raw data itself, right? So this is considered as ordinal because you rank the interval or the ratio measurement. Okay. So the third association test is whenever you have your data in frequencies. Okay. So this thing happen when you have two nominal variables, or one ordinal and one nominal, or maybe both of them are ordinals. Okay. So the most popular one is goodness of fit test and contingency test. Goodness of fit test, another name for it is the one-way cross-step analysis. Okay, one-way cross-step analysis. For the contingency test, it can be two ways or k ways. Okay, k ways means that k equal to 2, 3 or more. Okay, in discrete values, right? Contingency test. Contingency test when we have 2 by 2. Okay, so goodness of fit test normally is used to test whether the sample follow the proportions of the characteristic in the population. So goodness of fit. Let's say if you want to conduct a surveys, right? So the population consists of first year student, second year student, third year student. Let's say if your first year student is more than the second year student, the second year student also more than the third year student, then your sample must follow this proportion. Yeah, this proportion. It means that in your sample, the first year student must the number of the first year student must greater than the second year student, the second year student greater than the year student. So you need to find out the proportion, the ratio, okay, and then you need to perform the goodness of fit. If it's follow the ratio of the population for the year, for the proportions of the year for the students, then it means that your sample is fit to represent your population. Okay, this goodness of fit is very important, but many researchers who are doing the survey analysis ignore the test. Yeah, they didn't actually test whether the sample follow the ratio of the for the target group for their population. Yeah, this is very important. So the contingency test is the cross-step test, right? So these chi-square tests, we have so many chi-square tests, right? So do not confuse yourself. So the chi-square test that I'm talking about is the chi-square statistic for the goodness of fit test and contingency test, because these two measure, okay, testing the association between two categorical variables, okay, categorical variables. Now, when it comes to the estimate or prediction or forecasting, we have so many statistical methods. We have simple linear regressions. When it says simple, means that we have one independent, one dependent, and then you must make sure that they are linearly correlated. We also have multiple regression when we have one dependent, two or more independent variables. And then we also have non-linear regression, means that they are not linearly correlated. How do we know? You need to test it using the scatter plots, right? And then you need to check the pattern. How the points clustered, yeah, distributed on your XY axis, yeah, on your scatter plots. So maybe we have cubic regression, quadratic regression, exponential regressions, or polynomial regression, right? And then we have logistic regression as well. This is where we have dichotomous dependent variable. It means that the dependent variable in categories, 2 levels, okay? We have 2 levels for the categorical variables. So another name for the logistic regression is logic regression or binary regression. So they are referring to the same type of regression where the dependent variable has 2 levels, right? So the same rules also apply. The level must be coded 0 and 1, okay? So for the multinomial regression, when we have dependent variables with more than 2 levels, okay, a standard versions of the logistic regression. So when we have 3 levels or more than 3 levels, then the best option is the multinomial regression. And then if we are looking for the trend, seasonal trend, yeah, so we need, and then we collect data based on the time, time length or period of time, yeah, all right, and then we repeat it for, let's say, a few years, right? We have the cycle there. So maybe you need to check whether you can actually apply the time series. Okay, so another statistical method which is very closely related to the time series is the statistical process control. Okay, because the x-axis can also represent the time points. Sometimes not the time point, but the batches, yeah, the batch of production, right? But still the batch of production depending on the times, because the first batch, second batch, third batch from the same line, production line, also relate to the time intervals, okay, the timeline. And then maybe another statistical analysis is stochastic analysis. This is more on mathematical one. Not many people perform this stochastic analysis except for the mathematics students, yeah, mathematics student and the hardcore economics students. And then productivity ratios, this is more on the economics, okay. And then maybe you can see that if you are looking at the effect of a few dependent variables simultaneously, okay, at one time, the same time, yeah, you want to check. So you need to use multivariate methods. Okay, we have quite a number of multivariate methods. I just list out the most common one here. So the canonical correlation analysis is similar to the correlation analysis that we talked about just now, but this time we have 2 sets of variables. We are not talking about 2 variables, but 2 sets of variables, right? So this is known as canonical correlation analysis. Why canonical? Because we need to structure our data in matrices or in arrays. It's a bit complicated, but it's an interesting topic actually. So, and then we have cluster analysis and discriminant analysis. So these 2 analyses actually try to regroup your subject, try to find the underlying characteristic that belong to the groups. For the cluster analysis, you don't know any, you don't have predefined group. Yeah, you cannot predefine the group, right? So you have no idea at all. So cluster analysis try to find the closest characteristic among the subjects and then try to put them in one group. Okay, so discriminants is another way around. So you have a predefined group and then try to find the, try to discriminate, yeah, to distinguish every single one of the subject or the group so that they will be belong to a different groups. Okay, so cluster analysis focusing on the similar backgrounds. It's discriminant analysis focusing on the heterogeneous background. Okay, try to discriminate. Yeah. And then for the correspondent analysis or multiple correspondent analysis, this is where when you try to explore relationship among categorical variables. So this is the extension, the extended studies on the multivariate method for the chi-square test just now. Okay, for the chi-square test just now, right? And then we have factor analysis and PCA or the principal component analysis. This is where when you have a huge data, yeah, a huge items or a huge number of variables, and it's difficult for you to study all of the variables, and then you try to combine a few of the variables into few groups so that it will be easier for you to analyze your data. Yeah, analyze your data set. So this is where the factor analysis or the principal component analysis plays important role. So must remember one thing, factor analysis normally when you start from scratch. Okay, PCA we have 2 types of PCA. it's either exploratory PCA or confirmatory PCA. So you need to know in which states you are on. Okay, so you do not simply just perform the factor analysis or the PCA. You need to know what is the purpose of your study. Are you going to explore or are you going to just confirm it? All right. And then we have MANOVA. This is the multivariate versions of the ANOVA itself, right? So these are the, I think, this is my last slide. It's 12 p.m. already.
Yeah.
Yeah.
There is a question from
Okay.
audience.
Mm-hmm.
So the question is, Doctor, what is the alternative test of chi-square? If there exist many cells have expected frequency less than 5.
Chi-square.
Yes. Alternative test for chi-square.
Yeah. The assumption for the chi-square. What the question is just now? I'm sorry.
If there exist many cells have expected frequency less than 5.
Yes. Okay, for the chi-square test, there are only two assumptions. Actually three. Okay, three assumptions. The variable must have identical distributions. Yeah, it is actually not difficult to identify because it goes to the second assumption where the data in frequencies, right? So normally we have identical distribution. And then for the chi-square test, we have observed value and then we have expected value. Okay, so when the third assumption for the chi-square test is the expected value must be equal to 5 or more than 5. Okay, we are not talking about the observed value. Okay, this is the expected value. There is a specific formula to determine the expected value. So what happens if you have expected count or expected value for the chi-square test less than 5, right? Normally, if your sample size is big enough, we can accept up to 20%. It means that 20% of the cases having expected value less than 5. So if the percentage is not more than 20%, then you can still proceed with your chi-square test. Yeah, but this is only possible if your sample size is big. But if your sample size is small, it's kind of difficult for you to get expected count greater than 5. That's why go back to the notions of the first notions of the sample size just now. The bigger, the better. Is it clear?
All right, is it clear? Okay, Doctor, one more question from you. Okay, just now you said about if the population are from university student and the sample should be narrowed down to particular program. So if let's say I choose 5 university in Malaysia and the total 400 respondents, so I have to divide 80 students each or I can pick randomly.
I suggest randomly.
All right.
I suggest you do it randomly. Yeah, randomly in the sense of every single subject from that particular group has the chance to participate. How to ensure that all of them has the chance to participate? So normally for the survey analysis, let's say if you're using Google Forms, you can actually share the Google Forms with the leader of the group. And then the leader of the group will share the Google Forms in the WhatsApp group, isn't it? Sometimes if you belong to one particular programs, all of the students from that particular program belong to that WhatsApp group or Facebook group or whatever group, right? So whenever they have the chance to look, whenever they have the chance to participate in the surveys, yeah, doesn't matter whether they want to respond to your request or not, but you already fulfill the random sampling. Yeah, you already fulfill the requirement of the random sampling because all of them already received the Google form. Is it? Am I answering the questions or not?
Okay, Dr. Clear.
All right. Okay.
Okay,
So if you, yes. So let's say if you have other questions later, and then I have my email on the screen on the slide, so you can always email me. But do not expect that I can answer you right away. Maybe sometimes I'm taking a number of days, or maybe sometimes to reply. So just bear with me.
all right, so I think that that is the last question just now. And maybe we can end our session until here. And so thank you very much to Dr. Siti Rahayu for
Thank
the
you.
sharing session.
Thank you, Salwa.
Yeah, thank you so much. Clear, Doctor. I really love your explanation from the audience. Thank you, Dr. Siti.
All right, thank you, everyone. Okay, all the best. Okay, all the best to all of you. All right, so be active, and if you have any other questions later on, you can always email me. Okay, I will try my best to assist you. Okay, guys, thank you and have a nice day. Assalamualaikum.
Waalaikumsalam. Thank you, Doctor. All right, thank you for all the audience. Maybe we can leave the Google Meet now. Okay, thank you so much. Thank you also. So please join us, Postgraduate Live channel on Telegram. Thank you also, Nabila. Thank you all.